Let us talk about this problem. We are given a circular linked list. We need to delete the head node of this linked list. For example, if this is our input circular linked list, 10, 20, 30, 30 pointing back to 10, and if we wish to delete head, then this circular linked list should be modified to 20, 30. 10 is deleted. If your circular linked list has single node, then you need to change head to null, capital null in C++, null in Java. When you're programming in C++, you also need to ensure that in the delete operation, you deallocate the memory which was allocated to head. In Java, we don't need to do this because Java has automatic garbage collection. If your input linked list is empty, then we have nothing to delete, so we keep it empty. Now please pause this video and try to write down a function that takes head of a circular linked list as an argument, deletes the first node and returns the new head of the circular linked list. Let us now see the naive solution first. So to delete the head node, we need to find this node because the next pointer or reference of this node is going to change. How do we find this node? We traverse one by one from the head node and we look for a node whose next is head. Once we find this node, we can simply make the next of this as this thing and return this thing as new head. So first thing that you do is you find this node as current, right? You begin current from head and you run a loop which says that while current next is not equal to head, keep doing current equal to current next. And once current is here, what you do is you make current next equal to head next. So current next changes from head to this thing. Right? And if you're programming in C++, then you need to deallocate the memory for head. And after that, you return this as new head. You return current next as new head and your node is deleted. So this is how we do deletion in this naive method. Let's take a look at the implementations. This side we have C++ implementation and this side we have Java implementation. So what are we doing? We are checking for the base cases first. If linked list is empty, then we return null. If the linked list has single node, that case also has to be handled explicitly because in this case we need to deal with null, right? If the linked list is having only one node, then we need to assign head as null. In all other cases, we never deal with null. So this case has to be handled explicitly. Now other cases when you have two or more nodes, we have already talked about the solution. We begin current equal to head, we run a loop. While current next is not equal to head, we do current equal to current next. And once current points to the last node, we make current next equal to head next. We remove head from the chain of circular nodes, right? As we showed earlier in the diagrams. Now we delete head and we return current next as new head. So this becomes our new head. This is what we return at the end. Now this solution requires theta n time, where n is the number of nodes in the circular linked list. Please pause this video and try to think of a solution that deletes the head node in theta 1 time. This is slightly tricky solution, but you can try this for some time. Let us now talk about the efficient solution. The idea is to copy the data of next node to the head, right? So we copy this 20 to this node head. Now they both have 20, 20. And once we have copied this, we can delete the next node in theta 1 time. You can always delete the next node if you have reference or pointer to the previous node in linked list, right? And that is why we copied the data, because we can delete the next of head in theta 1 time. So we first copy the data, then we delete the next node. So we get the same effect as deleting the linked list. Why are we doing all this? Because we are getting constant time complexity here. Earlier, we were traversing and finding reference or pointer to this node, then we were deleting this node. Here, we are doing in theta 1 time. Let's now take a look at the complete implementation. If you see C++ implementation, it's slightly lengthy compared to Java implementation because we need to take care of memory deallocation. Let's now go step by step. We have a corner case. If head is null, we return null. If there is a single node, then we again have to deal with null. We need to make the head as null. So we delete the head and return null. And in all other cases, like this case, what are we doing? We are simply copying the next data 20 to head. That's what we do here. And then we store the head next. This is what we do only in C++. So these lines are required only in C++. In Java, we don't have these lines to deallocate the memory. So we store head next into temp. Then we make head next equal to head next, 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 head next, next. We need to basically remove this middle node, and then we delete this memory allocated to head next, and then we return the new head. And Java, we're just copying the data and making head next equal to head next, next, and returning the head. So this is a tricky and efficient solution to delete the head node of a linked list.